Well, I've popped around the corner from BroadcastShow Towers to Quantel here in Newbury, and we're going to go in and have a look at a new item of equipment they've recently purchased to help them with their R&D and manufacturing process. So let's pop inside and have a look. Well, here I am with David Throop here, and we are in the manufacturing area of your rather large Quantel building that you've got here in Newbury. Now we're going to talk about these items over here. Now this is a new 3D printer that you've got. Do you want to tell us a little bit about what you have here, and then we'll sort of go into a bit more detail while you're using it?
Yes, sure, no problem at all. Shall I hold this for the time being? So we took the option earlier this year to purchase a system from a company called Stratasys. And the Stratasys is a 3D printing system that prints in ABS plastic. And the reason that we went into buying it is all down to the fact that we wanted to shorten development cycle times. But the system is here, if you want to have a look and see. And in essence, it consists of two distinct items. One is a PC to drive it. And here you can see a component that is being made ready to print. And then there is the printer itself. Now, deceptively simple, really. You can just treat it as you would treat an office desktop laser printer, but instead of printing in 2D on a sheet of paper, as you can see inside here, we have some 3D pieces that have been printed overnight.
So, as you say, you can treat it similar to an office printer, but obviously it doesn't use ink. So, if people don't know a lot of people see these 3D printers and think, how on earth does it print a 3D object? So what material is it printing in, and how does it work?
So the printer takes two spools of material. Excuse me, I'll just close this door. This white material is a support mechanism that allows it to support overhanging structures, and this is fed into the container at this side over here. And then there is a spool of build material. In this case, it's red, but we have a choice of colours available to us. So we can have it in red or black or green or blue. And that is another spool that lives in this side over here. Both of those this is ABS plastic. And this material here is a special concoction that is soluble in a kind of a citric washing solution. And elsewhere, where there is a water supply, we have a washing station that will effectively take the manufactured component and wash off the support base that's been built underneath it.
Right, so but if you have something that is effectively going to be suspended inside, it would be effectively, while printing, suspended by this white, and then that's washed away, leaving something perhaps loose inside. When you see the ball on the inside of a box or something, the typical one that they use this sort of solution.
That's correct. Yes.
So obviously it has to be moulded somehow. Does it melt this ABS plastic in order to do this?
Yes. So what we can see here, in fact, on the end of this reel here, you can see that the material itself is about 1.5 millimeters diameter. But on the very tip here, you can see a very thin section that's approximately 1/4 millimeter diameter. And the way that it gets to that is that it is heated inside a nozzle. Here is the nozzle, and effectively the material is fed down. Oops, it's okay. The inside of this nozzle, and is heated and is extruded through a very small jet in the very end here. And the whole mechanism is controlled by an XY gantry inside here. And inside you can see this gantry, and the gantry moves in X, Y, and Z, and slowly this table moves down. Objects themselves are built on an overall support base, which is this black structure. So the black structure is, if you like, the foundation for everything. The white material is the support for the built items, and then you have the build material on the top of everything.
So as far as the size of the item that you can build in a machine like this, obviously you're restricted by this side, the support base, and height-wise on this machine?
We can build up to 6 inches on this machine. So it's 8 inches by 8 inches by 6 inches. This is an American system, so it's in inches. But in essence, we chose this because it was likely to be big enough for almost everything we'd want to do.
So as we're on to what you're going to manufacture in it, what do you actually use this machine for? Are you using it for prototyping, for manufacturing?
Okay, so over the course at the beginning of this year, I was looking at the amount of money we were spending in prototyping mechanical components. And the components that we were buying, we were having made out. So the mechanical design, which is essentially this, had been done, and that's a fixed time for that component. Then we were sending the files away. Then we were having them produced and shipped back to us. Then we would test them, look at them, play with them, decide that they needed changing, and it would go off, and every cycle would take 10 days.
Right.
And that was just way too long. It was going to take months to get through some of the projects. So we thought, well, there's got to be a better way. And so we investigated a 3D printer as a solution. And so these components here are not intended for full production, but they are mechanically accurate enough to allow us to actually test the form and fit. But the material, being ABS plastic, is not necessarily as strong as the real molded material, but at least you can make sure that everything works up to this point.
So as far as accuracy is concerned, these are accurate enough to prove that the design works in the final manufactured piece?
Oh, absolutely, yes. I have here an example which is a mechanical clutch assembly. So this is a combination of white plastic parts in this occasion. Even the shaft in the center here has been printed. And the whole assembly sits inside here. There are some black printed parts with springs. There are bearings in here, and everything was printed on this machine to the normal spec that you'd expect to make an injection welding tool from, and then just assembled and tested. To make this was 3 hours.
Right.
To have it done externally would have been a minimum of 10 days and many thousands of pounds. So the fact that we can actually make this, material cost for this would have been about £2, plus £3 for the base, so it's a trivial cost compared to the task of sending it outside.
And the advantage to Quantel is obviously the speed of development for new parts, new designs. You can get them out quicker.
Yes, exactly so. Part of it is about speed, the fact that we can now afford to fiddle a little more than we used to do. But we can also save costs as well, so we're saving a huge amount of money. Now, admittedly, we had the capital cost of the equipment, but I estimate that even at this point in the year, we've only had it for 6 months now, I think it has already paid for itself in money that we have saved by being able to prototype in-house rather than outside.
So a worthwhile investment for Quantel then?
Oh yes, very definitely, yes, absolutely.
And where do you see things going with 3D printing? I mean, obviously you're using it here for prototyping. Things always been developed at a massive rate. I'm not actually doing it yourself. Yes. Do you see a bigger future for 3D printing, even perhaps eventually moving to manufacturing?
Yes, absolutely true. We're already discovering that we can make use of this for making jigs and tools. And in fact, for example, this is a tool for molding soft rubber components. Right. So even though the material we print with is ABS plastic, the actual finished product that comes out of here is a soft rubber gasket. So we can make use of it to make things that you just need a few of, but would be next to impossible to get in any other way. So there are items that we make that are for production tooling use. There are items that we make that are prototyping for future production systems. So these will be part of a new system that we're developing. And there are parts that we make that are just speculative developments, just because we can see how things might work in the future.
David, that's very interesting. Thank you for letting us come and have a look here at your facilities. Always very impressive. You want to find out a bit more about Quantel, obviously, go and have a look at their website. In the meantime, I'm going to hand back to the studio.